So here in this certification, what all are the course material? So it's all about data. So if you again, if you are understanding, if you are opening OTT platform, if you are seeing, you can understand how you are logging in, where your data is coming, how you are getting your content. You are borrowing money from your bank, you see immediately you get a SMS notification and all. So if you can understand how it is happening, how the background of that data process is happening, so that is all. I would say that is all you need to know, how data process from one place to other. So this exam is an opportunity to demonstrate knowledge of core data concept and related Microsoft Azure data services. So if we talk about exam, 50% questions come directly about the concept, and the rest 50% uh, it's how that service or how that solution can be done on Microsoft Azure services. So this is the uh, bifurcation of those concepts. So like 20 to 30% questions comes from core data, then 25% relation, 15 to 20% from non-relational data, and rest of the part are from analytics workload. You get 20, 32 to 60 questions randomly selected. Exam time is 60 minutes, and in internet you will find a lot of theories. Like if you select like I'm a beginner, then you will get less question, or if you select I'm just trying, then you also get less question, easy question. Those are not correct. It's just a algorithm who selects, who pick a random number for you, and questions also. And one more point I would to say, I see like in organization and all, these certifications are given as a mandatory to you. If you have to save your job, you have to earn the certification. And what people do, they just go and start looking for the question dumps and all. I like I cannot detect you, don't do it, but that is not ideal. Means if you are having a certification, it's not a piece of paper to present like, hey, I have the certification. That means you should be holding that knowledge. And these are very not a very big thing. It's maybe a new thing for you if you are starting to learn about new thing. So it would be new, but it's not something impossible to learn. And this is like just I'll go through each and everything. Just I'm trying to explain the fundamental, like what are the stuff we should be considering, and who can do. One more question usually people ask. So everyone, if you are directly or indirectly associated with IT industry, you should be going for this, at least for this Azure Data Fundamentals certification. Because if you are in IT, you are directly or indirectly associated with data only. You are creating a solution around the data. You are doing the support and all, which is also to handle the data. Data is diamond. Data is like petroleum. We hear a lot of key phrases nowadays. In a way, yeah, that's all true. All whole IT itself is around data. And even now, I have been contacted by few person who are not even in IT. They are like in edtech industry, or they are salesperson of CRM applications and all. So they have to represent to their clients, yeah, how your data will be stored, how secure it is. We are taking it to Microsoft Azure. We are taking it to some other cloud. Your data will be in cloud, so there won't be any chance of losing of the data and all. So even they are also approaching to have this certification. So as a IT folks, it's like now a mandatory step. I would say. Okay, so moving to the course. syllabus. So it is divided into four: describe core data concepts, then relational, non-relational, and workloads. So this data concepts I have subdivided into basic and core. We'll go through everything from now. And whatever course material is there in my slide right now, it's all taken from Microsoft Learn page only. It's a legit and the one which is provided by Microsoft. Just I have jumbled the sequence based on the inputs and reviews I have been receiving from the audience. So I have jumbled the sequence, means the all related stuff add together, but the material is same as what you get on Microsoft Learn page. And these are the links you should navigate. Uh, Even on your Google or Microsoft Bing, you can simply type DP900 Microsoft Learn. You will get these two links. Those are interrelated. There also you can get a very good amount of and quality information about such things. So, any question as of now? Yeah, this is the page. So if you open the page, you will be landed here. Here itself, you have a study guide, sample questions, sandbox you can open and do some practice. So if no question, then I'll proceed next. So let's just start from very beginning. What is data? So data is a collection of facts such as number, description, observation used in decision making. Very widely used definition, bookish definition it is. And yeah, it's true. Data is just a collection, multiple facts. That fact can include number, description, letters, and all. And here I would add another line. It may have a literal meaning, may not, but must have to be a logical meaning. Let me put my slide on presentation mode. So what does it mean? This is a statement. What I'm trying to explain with this statement. So let's take an example. My name is Navneet. I'm from India. By reading this statement, you are able to you can drive some logic, some meaning from it. So this is about a person called Navneet, and he lives in India or he's from India. But if you see this line, would you be able to say what it is? Will you be able to drive any meaning just by looking into this statement? No, right? We cannot. And is it a data? As of now, we cannot say it's a data or not until we add a logical background. Navneet insurance details. So now this information is my policy, coverage, gender, some product, premium. So even this information is not complete. Which insurance company, what is the plan, what is other details. But it's still this line is now having a logical support. So yes, this is now a data. I hope, Simita, can you please confirm it's a good way to proceed? If people are understanding, means can anyone confirm? Any question, anything? Any question, anyone?
No, you're good, Navneet. Please keep on going.
Yeah, yeah, thank you. Sure. Okay. Well, so next topic that we should be knowing. So these are basic concepts. Again, I would say data fundamental is a foundational level knowledge. So types of data, how many types of data we have? So there are n number of way to defining the data, but I would define in the same way Microsoft Azure defines, or you say like all the cloud services provider, they divide the data into three category. First one called a structured. So what is a structured data? Then we have semi-structured. We'll go through that. Unstructured, third part. So here you have an example, and we'll go through one by one. So a structured data is generally organizational data that can be stored in the form of row or column. So whatever you put on a Microsoft Excel, you can say that is a part, that is a kind of a structured data. So organizational data means to say like insurance, organizational data, banking data, any a store if you are storing sales record and also those kind of data. So how that can be stored? That can be stored in a row and column based, just like on Excel we can put the data. So those kind of data which can be stored in form of row and column are called a structured data. But Excel, I'm just giving you example for understanding. Excel is not like a directly a structured data, because to be called a structured data, it should follow some rules, like all the rows must have same number of columns. Similarly, we will have more basic rules also. We will go through all of those in very detail. So every row is unique entity, means in a row in a Excel, it's not like uh, you can divide this one record into multiple rows. So one row should be considered as a single entity, unique entity, and all of them should have same number of column. So these are some basic rules to be called as a structured data. Again, organizational data, again I am repeating, because mostly big organization such as like banking, insurance, healthcare, sales, CRM applications, employee records, all such data used to be stored in this way. Then we have semi-structured data. What is it? So data which has a structure but cannot be stored in raw and column form. What does it mean? So data, a structured data is something where you see there is a ID, the name, age, degree. So if we are storing it in a table form, we can call it as a structured data. And let's store the same data in JSON format. In JSON, you see a student ID, then name is John, age is 18, degree BSc degree. The similar, the same data is now stored in a JSON format. So again, this is a structured data, but it is not stored in table format, and it cannot be a stored table format. However, this statement is not direct, like wholly correct, because in real time projects and all, we get such request, and get such requirement, we have to store JSON data in table. But this cannot be stored in table, so that we call it as a semi-structured data. Now a question arrive, why we need this? Already we have a very good legit way of storing such data, then why we need a Java, a JSON or XML and all, the semi-structured format? So again, we will go for that discussion also. Then third type we have is a unstructured. So unstructured in a simple way, which do not fit in any above category. What kind of data? Like audios, videos, movies, MP3s, PDF document, which is not in JSON format, which is not, which cannot be stored on table format, but still it is a data. It has logical meaning. Your PDF document, is it? This is for some reason. This is for some purpose. Maybe it can be your certificate, some important document and all. So it has to be called as a data. And but since it is not falling into our traditional way of storing in table and all, so we will call that as a unstructured one. Hope there any question, otherwise we'll move forward. So this until now we have just seen types of data only. We have a lot of things next. So now next we have types of a storage. So first type, relational database. Another type is non-relational database. Then third type, unstructured data storage. So similarly, the relational database which can store a structured data, non-relational database which can store semi-structured data, and third type which can store unstructured data. Examples are Microsoft SQL Server, Oracle databases. We have a lot of Oracle databases for relational database, and even these were started from 1980s. They were started giving us solution. MySQL is also from Microsoft. MySQL is an open source. SQL Server is a Microsoft solution for relational data that was also started giving solution by 90s. Then we have IBM DB2. Among all these, IBM DB2, you can say little advanced. They used to provide solutions and new innovations which are very widely acceptable for those organizations and all. And the rest of all, they just follow their footsteps. So but after this cloud and all, everything is started moving to cloud from on-prem. Now Microsoft Azure, even AWS, uh, they have surpassed this IBM's monopoly. Monopoly in the sense, not in the sense of how many clients. In terms of client, Oracle has w- uh, fully monopoly even now. But like on technological side, catering the changing requirements of clients and all. Now Microsoft AWS, they are moving ahead with from IBM and Oracle. Then we have non-relational databases. Traditionally, we have MongoDB, Couchbase, Apache HBase, Apache Cassandra, and here Microsoft has introduced their Cosmos DB. Cosmos DB is now kind of a crown jewel for Azure. We'll go through in detail for that as well. Next, for unstructured data, the best example of such database is present in your mobile phone, everyone's mobile phone. That's Google Drive. You have like 15 GB of free storage. For unstructured data storage, you can store images, movies, uh, MP3s, documents, and do not store pirated movies in Google Drive. They will block if they identifies it. For Microsoft, we have Azure Blob Storage as one of the solution to store unstructured data. So we'll go through this in very detail for all relational databases. Non-relational, first we will see how many types of non-relational data we have and what all are the solutions given for storing them at Microsoft Azure. Then we'll go through unstructured data also. Before that, we should follow some basic uh, concepts. So database and server, everyone must have heard these terms. What is database? What is server? Maybe you are knowing it, but here I'll just explain in a way so that like you can get the basics of it. So database is just an organized collection of data that can be easily accessed and managed. So it's just a storage where you can store your data, and it is not just of storing the data, it should be easily accessed and managed. Server is a computer program or device that provide a service to another computer program and its user. So server, I believe, I have get most questions like what is server. So server is nothing, just it's a computer program which act as a middle layer and it provides solution or connection to database to your computer. So one person asked me, I remember, he said, no, but in my office, I can see there is a server room So every time they say I am changing the server, they bring out some big box kind of machines. So those box kind of machines are on-prem traditional way, but that box is nothing but including the power unit and my motherboard and all. Even inside that, a written coding program is there, which is to support this activities. So let's say any day Nandadeep or Smita plan to give us some treat. They took us to Domino's. So Smita or Nandeep, they cannot go and take the pizzas from the kitchen, right? So they will place the order to a waiter. Waiter will take us our order. He will go to chef and pass on the information. Chef will prepare those pizzas, and then he will handle back the same to waiter, and waiter will give us. So waiter here is a server, kitchen is a database, and the chef is a database administrator. We are the customer, consumer who is looking for data, querying it. So it work like that. So in exam also you may get question that would be like server, what definition of server or something, or they give you some example. So related topic, provisioning. Provisioning is just a setting of the database server. So in order, like in you are in a project, so if you are doing a provision, means you have to first document, you have to first identify how many databases we have to put, how many servers, their compute power and all. First you have to identify. Based on that you do the setup. Inside the server also you can have databases. So that process is called provisioning. And nowadays any such action is also called provisioning. So even if you are setting up some new account or something, people used to call it as a, I'm doing the provisioning of that 100 users or something. But actually provisioning is, traditionally this is a definition for setting up the servers. So normalization, even I remember I got this question in my exam when I appeared for very first time. So what is normalization? So normalization is splitting of a large number of database into narrow, well-defined tables. So let's say if you have, again, I will give you example of Microsoft Excel. So if you are storing a huge data, which is having hundred of columns, now on Excel itself, you can imagine how difficult it is to navigate back to if you have any doubt or any requirement to find out some particular information of a particular record. So instead, it is better to split them into 10 or 10 different sheets with 10 column each. So all related information will be clubbed together, stored together. That that we call it a normalization. So why this normalization is that important that we are discussing here in data? Yes, it is very important because when you are storing your data, it is not just for the performance or the compute power required to process that, but it's also about the security. So now on Microsoft Azure, we have n number of security options. But if you go back in time, like 10 years and all, so let's say in your bank, there are different roles. Some are junior staff, accountants, then other people. So the security was provided in a way so the accountant has the access to see all of your transaction and all. He can see how much money you have, what is your KYC information and all. But clerk level, why he should he should see the confidential information. So his access would be limited to one or two tables, which would have your personal information or just like final account balance and all. So earlier, the normalization was very important, not just for performance, but also for security and access related stuff. Then one of the very important topic, ACID principle. So if you remember, just a few minutes back only, I was talking that Excel, I'm giving it as example, but calling it out as a, a structured database, it's not good. Like if we are calling something as a structured data and a storing in a structured database, relational database, this should follow some principle. So what are this? So it must be following some basic principle, I would say. We call it as a ACID, it's not acid. It's always we have ACID. So check one by one. Atomicity. Atomicity, what it is, it guarantees that each transaction is treated as single unit, which either succeeds completely or fails completely. So if you are entering any data on any relational database, a structured type of data, so if you are entering some a special character in numeric field, again for banking example, if you are entering account balance as 5 at the rate 6, so it's not a good account balance. It should be 506, 516. So anything, it always be containing only the numbers. uh, if it is in like paisa also, it can uh, store after points, but again always it will be a number. So it shouldn't be a case. If you find, or the way or your job is finds that the data is having one of the field incorrect, so let me add whole row leaving that one particular column behind. So that cannot be a case. Either whole row will go into it or whole row will be filled, because the single row is single unit. Let me try explaining in the way. So in relational database, columns are different information for rows. So rows are one row is one single unit, one single piece of information about one particular area, one particular thing. So either it will go completely succeed, or either it should fail completely. And a full complete failure means full complete failure of that one particular row. So that guarantee we call it as a atomicity. Then next we have consistency. So it ensures that a transaction can only take the data into database from one valid state to another. So what does it mean? So here assume consistency is why it is required. So I was thinking for an example. So let's think I am transferring some money to my brother's account. So there is a table which is storing my account details as well as my brother's account detail. We have a bank account in the same bank, current account or savings account. So now if I am transferring 10,000 rupees to my brother's account, the consistency would say my brother's account is increasing, the account balance field is increasing by 10k. In the same time, my balance should decreased by 10k. It shouldn't be a case like his account balance is increased by 10k, but database was not able to capture the change of decrement on my account balance. So just think how big impact it can make on daily business. It's just on not just on banking but anywhere. So consistency rules must be defined and those rules must be followed if we are continuously ingesting the data and working with the data. Next, we have isolation. So it ensures the concurrent execution of the transaction leaves the database in same state and would have been obtained if the transaction were executed sequentially. So isolation means, so when we are doing multiple execution, of transaction, and concurrent execution of transaction means to say multiple people are working at the same time. Maybe I am like uh, entering some new data, uh, in the same time other person are running the queries, taking out the data on terms of views and for his analysis and all. But after all such thing, database must be remained as it was. It shouldn't be like I have run the query, I have checked the data and it got updated or changed. Also, if the transactions were executed sequentially means, so if I am entering the data into a database, so the existing stuff cannot be tempered. However, this can be done like we have a slowly changing dimension theory where we have multiple type of slowly changing dimensions, SCD type 1, 2, 3, and 4. But here what I'm trying to explain, the isolation is important. So concurrent execution of transaction leaves the database in same state. Uh, I think I'm just repeating myself over the same thing. Please put your questions and doubt if you are not able to catch. So again, just I'll take one more line and we'll close this isolation. So it ensure, so if we are sequentially executing, so the data must remain same in the like previous state. Last we have durability. It ensure durability guarantee. Once a transaction has been committed, it will remain committed and is even if the system failure such as power outage and crash. So uh, like we have seen, we must have such experience like we are transferring some data in our pen drives, in between light gone, laptop crashed or something, and the same time data is also gone. So that shouldn't be a case because this is databases used to store huge organizational data which has a lot of business meaning and all. So if a customer is putting his data into any of a database, then it there should be some guarantee that it should be always be stored. There should be some pro- uh, there should be some system backup and all, which guarantee that if transaction was committed, it was entered into the system. If power outage happened, crash happened, it always be remained in the previous state. And this is very important in terms of examination. You must be getting one or two questions and direct questions. Just they will give you the definition. You have to choose what it is. Not like in the same statement. Maybe they will give like uh, so I am moving my this much count from this database table to another one. The after the transfer, the number was increased at the second place, but it remained same as the first place. So what rule was violated? So in such type of questions you get in your examination, you have to select consistency there. Next topic, data ingestion. Data ingestion is just a process of capturing the raw data. Raw data can be anything. So let's say there are many point of sale system. If they are capturing data and storing it in their own embedded services, like uh, the software or application has a local storage, and after some time we are picking up that data and then processing it to load into any database. So that is just an example. Maybe raw data can be anything. So let's say for your system you are getting data from established RDBMS, relational database management system, where the structured data is stored. So even that, if you are taking that data for your own purpose and if you have to do some modification over top of that, so that is also data ingestion. So data ingestion simply it is just taking the data from outside. Outside can be anything, even in your own uh, single subscription. In your one resource group, if you are taking data from other resource group, that is also a data ingestion. And if you are not like catching what is resource group and what is subscription in cloud, like these are little cloud based um, terminologies. So if you are aware, it's okay. If you are not catching, that's also fine. Again, data ingestion is just capturing the raw data or data capturing from outside for one particular purpose. Next, data transformation and data processing. The raw data might not be in the format as you need. It it may contain anomalies. It may uh, be present in some other format. A very simple example: maybe at the raw place, the name was stored as first name, last name, like Navneet, Naman, but at your target, you need a full name. So even that comes under a data transformation. Maybe you are entering the data, your staff and all who are at the point of sale system, they are entering the data, but not following full complete data ingestion rule. So sorry, not data ingestion rule, means the business rules, like they are leaving some of the important field as blank, and system is allowing that because those applications are designed in a way that can allow. So if those are not good for your further processing and all, so those anomalies, to detect them, either correct them or drop them, all comes under data transformation, data processing. $1 million question: what is Azure? So Azure, all are same. Different people call it as a different pronunciation, but Microsoft Azure is just referred as Azure. It's a cloud computing service created by Microsoft for building, testing, deploying, managing applications and service through Microsoft managed data centers. So in other word, you can say it's another business unit of Microsoft. So one business unit of them is a Windows, which is having several products of related to operating system. Similarly, they had a SQL Server as a Microsoft database management before coming of this Azure. Similarly, they have other service which provide email service. Similarly, they have some products also: Microsoft Word, Microsoft PowerPoint, Microsoft Office. Together, we call it as. So those are different business units of them. Similarly, Azure is another business unit, and this deals with cloud computing services, all related to cloud computing. Their portal is Azure Microsoft. Here the link is given for learning of the basics. So one basic question, however, this is a topic of AG 900 certification, Azure Fundamentals, but I have just put here to understand. So when you put your data on cloud, so you don't need a local storage, but it doesn't mean that the data is not required a storage. If data is there, so you are storing it in a cloud, then you are accessing it through your valid credential through internet, but the data will be stored at some physical place. And where it will be stored, so these blue dots you see, these are the geolocations where they have a data center. Even in India we have three data centers: west, and they call it as a West India, Central India, South India. So this west and central both located in Pune. South India data center is in Chennai. Along with that, in US, Europe, we have a lot. China they have, but they don't business directly. So they have a different subsidiary at China, which which runs independently, but that is based on Microsoft service, because they have some political issues between US, China, and all. They have banned Microsoft, China's Chinese government. So, but business brings them together. Similarly, on Australia, you can see so all these blue dots. So now this image was taken long back. I took it from internet only. Now they have increased more data centers. These data centers are subdivided into availability zones, and you have n number of way to choose your subscription. Like you can choose multiple availability zone inside one data center. You can also go for geo reductant uh, service where you store your data at one data centers. At the same time you make a replication which is completely like geo reductant, means away from geographically manner. Like you are storing it as a Chennai and you are putting your replication at UAE. So even some by God grace shouldn't be happening, but even some kind of natural disaster happens at one of the data center, your replication should be stored and been safe at other one. So once you go over all of these, you will like learn more. However, this topic is for basic for AZ 900 Azure Fundamentals. If you are also planning of if you have obtained, you must be knowing this things in detail. We will let's proceed on data side. So few more important terms like data querying. So data is stored, it is ingested means the raw data was picked, transformed, now stored. But what is the meaning of just a storing if we cannot uh, query them, take them and analyze them? So there can be a number of reasons of query and analyzing. Maybe staff data is there, accountant person need to check the employee details so that he can process the salary. Even for the processing the salary he may need multiple information, what is his pay band, what is the last salary he drawn, what is basic salary and all. So for that he need the data. So for the same, data querying is the process of seeing the query and seeing the stored data. Second, data visualization, interdependent topic, data querying and visualization. It is represented in tables such as rows, column, documents always be intuitive. So visualization is like you queried the data and then looking into in terms of table, like a row and column based. So that is called data visualization. Then access. So when we are talking about data querying and looking, so we should be thinking of access. So who can see? Can anyone see? Can I go and see uh, Punjab National Bank's customer details? Can I see ICICI Prudential Insurance customer details? No, because the access will be given to the concerned people only. So this topic is originally it's a access. Just I'm giving it as a context of Azure because like we have to talk in terms of Azure. So read only access. This means the users have ability to read the data, but they cannot modify. So whatever data is present, I can simply see if I have a read only access. At the same time, read write access, this is to them who has additional privilege. They can alter the data, they can write the data. Then third, owner privilege. Who is the owner? Owner means he has the full access to the data of managing. Even they have privilege of managing the securities like new users, adding a new users, removing the existing one. If new person are coming, they should be allowed for some privilege of reading or writing the data. If an employee is like exiting the organization, then his access must be removed. So this access account will be called owner privilege. And roles, it's mostly for like the one who are professionally working in the world of data. So in Azure, like Azure Database Administrator role, uh, it is Azure Database Administrator is responsible for design, implementation, maintenance, operational aspects of on-premise and cloud-based database solution that is built on Azure Database Services, SQL Service. So again, the name from name itself you can derive. The administrator is like the topmost administrator who is responsible for designing. I want this kind of solution, this database, this much amount of compute power and all, and along with maintenance and how it will be operational over the time. Then we have data engineer role. A data engineer collaborates with the stakeholders to design and implement data related assets that include data ingestion, pipeline cleansing, transformation activities, and data stores for analytical workloads. So data engineer is the one who actually take information, collect the requirement, design how that can be achieved, and try to implement all such related data sets. And it include how data ingestion will be done, like how the sourcing of the data of raw data will be done, cleansing, because this term, if you are not clear, like if we are getting the data, there can be a number of process in between. If we are transferring the data, that will create some cache, that cleansing is also required. And also it is also like if we are just keep storing the data, we may be seeing like incorrect data, duplicate data, junk data as a stored. So over the time we have to do the cleaning process as well. Then transformation and data stores for analytical workloads. So for example, again, if my data was taken as some 100 rows or something, 100 columns or something, but the person who wants to see what was the sales report, so it's not uh, ideal for him. Let's say I am a owner of a electronic shop. I am storing my data as like I sold 100 units of TV, 20 units of fridge, 30 units of washing machine. But my owner wants to just see how many electronic devices were sold. So I need to do a transformation. I will add up all the sales of TV, fridge, and washing machines together and will store in a separate table with a column called total number of sale. So creating that internal design itself is a duty of data engineer. Then last we have data analyst role, and these are like a standard. So in real world there are like n number of other roles are present. So data analyst role is something like enables business to maximize the value of their data assets. They are responsible for designing, building scalable models, cleaning, transforming data, enabling advanced analytics capabilities through reports and visualization. So if you see, many of the things are common between their role, but the difference is their purpose. Tasks are quite the same, but their purpose are different. So what data analyst is doing, he is like taking up the data, transforming and using that to create reports through let's say Power BI. So Power BI is another very uh, power platform Microsoft is providing. So earlier they launched this as a part of Azure, but it is not now a separate business unit, Power Platforms. So Power, they are giving a option of data visualization as a Power BI application. There you can ingest a huge data. Based on that, they have a predefined what can I say, like predefined data visualization options like pie chart and all. So that can be done. So data analyst, he will also do a similar task. Will take up the data, design, but his part is like business guys, management guy. They want to see on what state what sales were done. in banking, how many person went for loans, how many, even inside the loan, how many were opted for car loan, how many were opted for education loan and all. So if he is doing the analysis from that data, he is like data analyst. Any question as of now? I see no question here. Okay, let's move then. Now we are entering into some uh, real like concepts, I would say. So primary key is in a relational database. It's a column that contain values of uniquely identify each row in a table. So earlier we see in a relational database, every single row should be must be uh, considered as a unique entity. So there must be some column which must contain unique value as well. Now again going back to our bank example, name, can it be unique? No. There can be n number of Navneet, there can be n number of Nandeep. Similarly, their information, their address, their district, state, even a village, inside a village or any colony, you see multiple people are having same uh, name and even surnames. So there must be some column which can identify them uniquely. Let's give them unique account number. So two-person cannot hold a same account number. Similarly, in your identification, two-person cannot hold same PAN card number. Two-person cannot hold same uh, Aadhaar card. So these identification numbers, these are the unique. So either any column which is which is containing unique value from the business perspective, that we can take it as a primary key. However, this is called surrogate key. So how all the keys, all the columns which is uh, having a unique value, those are surrogate key. Now from there, either we can take one of them and make it as a primary key. If it is not advisable, violating any of the business rule, we let's add one primary key column by ourselves. So in database, while setting up the database, let's add one column which will be like a serial number. The serial number or something, if it is a sales record or something, let's give them as a sales ID, sales record ID. Even in some situation, if a table name is given as a customer, then customer ID. On top of everything, on just on table we put another customer ID just to make it as a primary key to as a unique identifier. Next, foreign key. So foreign key, group of columns in relational database that provides a link between two tables. So here again I'm telling, so we talked about normalization. Normalization is splitting a big column tables into a small column, small different tables. So if we are splitting up our data, we have to make a relationship between them. So how can we say, so whatever information is given in table 1 for row number 1, for the same row number 1, uh, this other columns are present in table number 2. So the primary key should be same for them, and primary key of second table will be called as a foreign key. So PKFK, you may have heard PKFK constraints for primary key, foreign key constraints. So it's like this columns key means the, it's not a different thing, just a one of the column of that table which is used to join between them. So for example, from next example I'll explain more again. So then schema, next topic is schema here. So schema is nothing, just a overall representation of a set of tables inside a database. So either schema equals to database, one database is equal to one schema. In single database, you can have a number of schema making a combination of different tables. So what is a star schema here? Term you see written star schema. So there is a fact table in middle and related informations are given around it. So again normalization, let's say it's a banking table for banking transaction. So one fact table was created with the basic information name, account number, or better let's have the same example like product key, order key, due date key and all. Now related information to one of the column, let's put in a different table. Instead of adding this two column here again, adding this two column again later here means adding all this thing. Let's subdivide. So main table, fact table will contain the basic detail and all related information will be stored across around. Now here, how we can see this information here is for what row. So there we will have the same one column as a common. So primary key of this table is foreign key for this table. So if it is equal to any of this one. So the again I will give you example of a banking. Let's say there is a fact table, middle table, which is containing your account number, your name, your Aadhaar card, PAN card, and basic details. Now you are having a debit card. There will be another table storing for only for your debit card detail. How? With your account number. So second table will contain the account number, will be joined through account number. If you are holding a credit card, third table will be there just to store the credit card. Now imagine I don't have a credit card and this normalization is not done. So there is no meaning of storing such record because different people can have different products taken. So if if someone wants to see that this in let's say credit card table, credit card in the credit card table account number is there and credit card details are there, he want to see what is the name of this account holder. Then what is required? Then a join is required between this dimension table and fact table. So dimension all are on the edges and the fact is the middle level. So there we can see for this account, let's say account number, this is a credit card number. So account number, we can go back to fact table and from there we can see what is the name. Now possible, there can be a possibility that from the credit card, the data analyst or bank employee need to see what is the debit card details of him. So how it can be done? Account number, they can join through fact table and the primary key, foreign key of this table, they can join back. From here, they can derive information from here. So this way of storing the relational database, we call it as a star. A star means there is a middle uh, fact table and many dimension table on edges, something like a star. Yeah, here you can see the example. So there is a like let's say big table. Now this particular information given in a particular box, if we took out that out and here we can join. So let's say sales order ID is 06 something, the product key is 594 and now I want to see what is the reseller key. So from here I can go there and there from I can find a reseller key. So it's mostly for it is mostly for big large tables which is normalized and the way of storing the data. It is in a short form it can be said. So next we have snowflake schema. So star schema is still it's a kind of theoretical thing I would say because in real world the requirement and the way it is required to be stored are quite different. So a star schema, you will get a very less chance of you can store your data into single table or into a star schema, because just with my last example only, credit card. Now inside the credit card itself there are multiple ways. So if you are a HDFC customer, you have money back credit card, you have millennia credit card, platinum, then gold. So they give it as a different names, they give that to different customer based on their income and their performance. So even from the fact account number, there will be a dimension for credit card inside. Again it become a fact for related credit card information, like millennia credit card, platinum credit card, um, some other service and all. Similarly, maybe from account number there will be a loan. Inside the loan there will be like a car loan, home loan, um, other loan, bike loan, home loan. There can be a possibility that same customer is opting for multiple. There can be a possibility that one customer is opting for just one. So again, the dimension itself is a fact for multiple dimension again, that we call it as a snowflake schema. And in real world this is like, this is the most widely used, most widely accepted, and any design, like mostly go it is designed as a snowflake schema only. So with this one I would say basic concepts were covered. Now I will enter into core data concepts. So we'll see for any queries or question quickly. Any question, query? No. Okay, then I'll move further again. So next we are going to see the core data concepts. So first topic, data workloads. So there is two kind of data workload usually we have: batch data, streaming data. From the name itself, batch data, which is coming on batches. So let's say there are some point of sale system which is storing the data, and they store, and then after some time, like after 4 hours or 3 hours, the data was taken, ingested to next system for further processing. So that we call it as a batch data. So batch data, we had a lot of things, like either it can be a daily basis, weekly, monthly, hourly basis, 3 hours, 4 hours. Some places they used to process in just in 5 minutes, 10 minutes, calling it as a near real time data. Maybe you may have seen, like you are asking any customer care, see, so I have made these changes, or you have updated your mobile number at bank and they are telling, okay, wait for 3 hours, it will be reflecting by then. Or sometime if you are signing up for application, it says you have to wait for 30 minutes, after that the change will be reflected, or wait for 50 minutes. So what is happening in background? So your data is being stored at one place. After a 50 minute or 30 minutes time, it will be processed as a batch. Once it will be processed, it will be flow to further DB and all, and to that DB also, from which your UI is associated, your Android app UI, your website UI is associated. So those that way is called batch data. So how usually this happens? So local data used to be stored in CSV, comma separated, pipe separated, tab separated. Comma separated means a comma will be placed between two columns. Pipe separated, pipe you see above your enter button, you see the pipe. So if data is separated, like two columns is separated with pipe. Similarly, tab means there is a tab space. tab between two column. So use that used to be stored in the same way. CSVs are then processed further. Then now we have Apache Paraquet. Apache Paraquet is like a very extreme, uh, like efficient way of processing the high number of data. So, for example, I would say if you have around, if you are storing your data in a text txt notepad and it is having like 10 lakh rows, the size will become like 1 GB. If you convert them into Apache Paraquet, the size will be like 20 to 25 MB only. And it happens like, you can see, if you want, you can try, you can get many online editors also, converters, Paraquet converters. So just put a CSV which with a huge amount, convert them into Apache Paraquet, and there you will see the size is very less, and the processing from the Paraquet is also very efficient. So blob files are large files containing data to another database. So this is batch data. Next we have streaming data. Streaming data is something when it processed whenever created. So if you are running a YouTube, so YouTube, you are getting data continuously. You are on Netflix, so your data is streamed, means on real time your data is being streamed, you are getting it. Event of IoT hub, like any IoT Internet of Things device, it has to be flown on real time so that your query will be taken. And not just this example, on uh, other business example we can give. Whenever you do a purchase, immediate you receive a SMS like your money was deducted. It cannot be a case like the money deduction message is coming after like 5 hours or something. In between, if the account balance remains same as previous, people can do a number of uh, forgery. Uh, they can withdraw more money than their actual bank account statement. So streaming data there also, you see, in one liner, data is processed as it is created. Apache Kafka. Kafka is like a traditional way of and existing, one of the most efficient open source given from means provided by Apache. So that is a one service for streaming data. So that was mainly batch data, streaming data. Exam perspective, yes. If you are lucky, you can get some easy question differentiating between batch data and streaming data. You might be getting some question like, you are watching a YouTube video. Is this is a batch data or streaming data? Even yeah, that example I remember. One of my friend was saying. So he had this question. So in the bank itself, uh, the bank officer said, your email update will be reflected by next day, but uh, when you withdraw some money, the account balance change started reflecting immediately. So select which one is streaming, which one is a batch data. So batch data is the one where your email is getting updated after some time, like 1 day or something, and streaming data is something which processed immediately. So next we have data analytics. So data analytics, why it's very important thing, I would say. In terms of exam, like you must be getting 2 to 5 questions. So like I have talked to more than 80 people who have attended this examination, and no one was there saying they got more than less than 2 questions for related to data analytics. So what is data analytics? First, two part here. So one, like the problem of too much data. If you have millions of rows and if you have to find a trend, it's impossible for you. So how you can do? you can ingest the data to Power BI. From there you can try a very good visualization. Like this you will be able to track and say, for example, like here you see this skyscraper that represent that here the sales was high, ticket sales in Seattle, or something. I have taken this screenshot from internet only. In cricket matches we see they represent some, they call it as a Manhattan something. So what they do, overs 1 2 3 4 till 20, and they put this kind of a skyscraper which represent how much run was scored in which over. So these are the effective way of data visualization from huge data. So now coming to analytic technique. So this is the actual topic from where you are supposed to get more questions. So five kind of analytics. So analytics means the analysis of data and finding out the cause and other details. So one point you should consider when you are doing analytics here means when we are learning this one, it's not like you are going to market asking the people. You have to find the details and other stuff from the available data which is present to you as a data analytics. So first kind, descriptive analytics. So descriptive analytics is simply just you looking into the data. You have to identify what happened, like what was the today's sales, how many service appointments were booked, what is the net margin, what is the service of existing data records. So analyzing this thing, like simply what happened. I have a huge data with me. I have been provided a huge data set. From there, I just have to find what happened, how many sales happened for product A, how many sales happened for product B, how much money was deducted, how much money was uh, withdrawn from table A, how many money was submitted at counter B, how many tickets were sold, how much premium I have got, how many defaulters we have for this month, how many defaulters we have on second month. So just simply getting what happened is called descriptive analytics. And again, these five topics are very important. Again, you will get 2 to 5 questions, and if you understand, you are understanding like a very big thing. And if you understand correctly, you don't even need not to do some later learning or revising and all. Other type, diagnostic analytics. So why did it happen? So here you just had to find out what happened. Now you are trying to find out the reason. Why did it happen? So why did it happen? How you can get that? You have to drill down into the data. So why happened? Like we have to just looking into data. We have to see change of sales per location, comparing one region against another over the time. We see customer who had their problem solved on first visit was customer who had come back for two or more visits. So you, if you see something, the sales were increased immediately, sales were decreased immediately, then why it happened, why sales were increased. So that we need to find just into looking into data, available data better to say. So maybe it was a festive season, so sales were increased. After the festive season, sales were decreased. Maybe pandemic was there for like couple of years, so many products, like many business went off. People were not spending on luxury items and all. So what we are doing the diagnostic analytics when we are trying to find why did it happen. Third, predictive analytics. So predictive is what will likely happen in the future. Just looking into data, we see the pattern. Like if if the sales were high in this festive season, definitely the same. will happen on next year as well. Maybe the sales will get more increase day after next year onwards. So what will happen in likely in future? This is what we do as a predictive analytics. And very good example, your portal, Azure portal, when you have a subscription, it predicts your bill, what you can get at the end of the month with the available like actions. The way your data is getting ingested, if you have elastic model where you left everything on Azure, like whatever data will come, just keep ingesting it. So there, based on that inputs, it is predicting that this will be your bill. Maybe the time December to March, people used to buy more insurance policies just to save their taxes. So predictive is like after seeing every year's pattern, insurance company can predict, they can be prepared. At that time they need like more documentations, paper, maybe more effectiveness and all. So organization usually call this one, this they do for predictive, as it's like very important for every such business. Next, prescriptive analytics. Prescriptive is something, what should I do? Best example, Google Map. So when you search on Google Map, now 3 4 years, from three last 3 4 years only, they have given this feature. They don't just give you the path but also suggest, if you take another way, you can reach like 30 minutes before. In some other pathway, more blocks are there, so you can alternatively you can take this pathway. And it's not like this is a from, let's say, first suggested path one, it's a 10 kilometer, maybe from second one it will be 15 kilometers by distance, but because of the availability and freeness, you can reach earlier. So that we call it as a predictive, prescriptive, sorry. Last, cognitive. So cognitive, for all of this, if we are using artificial intelligence and machine learning, and most if your data is not unstructured, means if you have to do analysis over images and all, you must be needed a machine learning model. In that analytics, you can call it as a cognitive analytics. And it's not just simply that one, maybe like reading Twitter to determine brand sentiment. Let's say uh, now social media use this very well. Let's say they are they are taking money and advertising something, but normal people sentiment is against that product because of any reason, because of politics, because of demographic, or maybe their religion's belief, whatever. If people are against the one, that one particular brand, and if that social media is keep advertising that, over a time, that negative impression over that brand will get transferred to that social media platform. So it's become very important for them as a business perspective to understand people's sentiment as well. How one can understand people's sentiment? Maybe we have a lot of now Azure services over machine learning, artificial intelligence. So if any of such services are taken as a help to do the analytics, will be called it as a cognitive analytics. And one like quick thing on examination, uh, like uh, uh, suggestion. So if you see artificial intelligence, machine learning, images and all, that will be directly a cognitive analytics. So next topic, ELT and ETL. So you might be hearing this fancy words, ETL, ETL tester, ETL developer. The jobs are very high. The demand is high for ETL guys. So E stand for extraction, how you get the data. Load stand for loading, loading into your database. Transformation, T, transformation is just converting your data into raw to find. And raw means it's not like complete raw, even of a different format. If you are converting to your own required format, that calls transformation. Now ETL and ELT. So if loading happens first, transformation later, that's ELT. And if transformer happens first, loading later, that's called ETL. This is a traditional way. All the traditional applications like Informatica and all, those are ETL. Uh, Microsoft Data Factory, they offer ELT. They first extract the data, do the transformation, and then load. Sorry, they load the data and in parallel they do the transformation. So this is ELT. How it can be done, that we will check in our last topic. There I have like created a slide for that as well. So for the time ETL, first transformations like Informatica. So what happened? Data is extracted, then the transformation happened on their backend. Their transformation engine transform the data, create the cache of transformed data, and then the cache is later loaded to destination. And there like the cleaning of that cache becomes very important. Like every month at least, we have to do the cleaning of that cache on server, on pipeline, and everywhere. To overcome that problem itself, ELT arrived when it came to cloud. Because imagine if you are just having 1 GB of cache every day, that cache itself will cost a lot to holding that much, and cleaning and all, it will be like a overburden. So better to have ELT, like whatever you extracted, just load in parallel, transform. Like how you might be thinking how, like extracted first name last name, a stored extracted first name last name. In next table there will be other column, full name. Both process happening at same time. It support both batch processing and stream processing. So as of now we have covered core data concepts only.